So we're going to look at the definition of weight. So weight is actually another type of force that measures the effect that gravity has on your mass, and it's actually measured in newtons. So the word weight is often used to mean, when we use the word weight in context, we often mean it to actually mean mass. But they are actually quite different terms, and so it's important that we make the distinction between what they are when we're using them in formulas for things like force and for stress and those types of formulas. So again, weight is actually a force that we're looking at, and it's affected by gravity. So let's look at sort of an example of force and weight on Earth, and then we'll look at maybe the idea of force and weight on, say, the moon. So for example, on the Earth, say that your mass is equal to 70 kilograms, or approximately equal to 154 pounds. Your mass doesn't change whether you're on Earth or whether you're, say, on the moon. So your mass would still be the exact same thing. It would be 70 kilograms, or approximately 154 pounds. So that actually is not affected by whether you're on the Earth or whether you're on the moon. But weight, on the other hand, is affected by gravity. So that's extremely important to think about, that the gravity is what's actually affecting your weight. So gravity on the Earth is 9.81 meters per second squared. So note it's an acceleration. The gravity on the moon, though, is actually equal to 1.62 meters per second squared. So that affects greatly your weight. So your weight on Earth takes into account your 9.81 and how much that has an effect on your mass. So your weight on Earth is actually equivalent to 686.7 newtons, and your weight on the moon is actually equivalent to 113.4 newtons. So mass never changes. It doesn't really matter whether you're on the Earth, the moon, or wherever you actually are. It never changes. That's what your mass is. But weight will change, and it will depend on what the gravity is. So it's important, again, to make that distinction whenever you're plugging into formulas, that weight is actually a force. And so commonly we actually interchange the terms, but it's important to make sure that we are actually using them correctly in terms of our unit. So weight is another force. So it can be calculated with the following formula. So these numbers I got with the following formula. So weight is equal to mass times gravity. So our weight is measured in newtons, mass is measured in kilograms, and gravity is, like our acceleration component, is always going to be the constant 9.81 meters per second squared. So notice it is just the force equation. So remember, force was equal to mass times acceleration. In terms of weight, the specific force, we change force to weight, and we change our acceleration to gravity. Mass stays the same in our particular formula. Again, you don't have to memorize this. If you do go to your resource sheet at the bottom, you do have weight is mass times gravity, and it does give you the constant that gravity is 9.81 meters per second squared.